Hi guys, so today we're reviewing everything you need to know about Newton's laws, applications, and forces for the physics regents. So we're going to do a little overview about all the key concepts, and then we're going to do some practice afterwards. So what is a force? It's a push or pull exerted on an object which causes acceleration, deceleration, or change in direction, and it is measured in newtons. So the first thing you need to know is Newton's three laws. So the first law is the law of motion. This states that an object at rest stays at rest and an object in motion stays in motion unless an external force interferes with it. Also, an object's mass is considered its inertia, and the more inertia you have, the more force it takes to change your motion. The second law is the most important, and it's basically the equation F net equals ma, which says that the sum of all forces acting on an object is equal to mass times acceleration. The third law is a key concept used in questions, and it says that for every action, there's an equal and opposite reaction. That basically just means that if you hit a wall with a force of 40 newtons, the wall is going to hit you back with a force of 40 newtons, which is why your hand wouldn't go through the wall and it just hurt. Now, moving on to friction. Friction is the force which opposes the motion of two surfaces in contact. So like the friction between a tire and the road when a car brakes is what keeps it from moving further. For our friction equations, you're going to need to know what coefficient of friction is, and it's represented by the Greek letter mu. It's a unitless number that represents frictional force between two surfaces, and the number depends on the texture of the surfaces and whether the object is static or kinetic. Questions usually ask you to figure out what mu is or what the surfaces are. Now onto static and kinetic friction. Static friction is the force which keeps an object at rest, and kinetic friction is the force that acts against a moving object. The value for static friction is always greater than kinetic friction because it takes more effort to make an object start moving than to keep it moving. Now let's quickly talk about the four most important forces for this review. We're gonna briefly talk about the equations for these forces and then go more into depth about it later. So in this context, gravitational force, or Fg, is just your weight, and it can be calculated with Fg equals mass times gravity. Normal force is like a supportive force that is perpendicular to the surface which the object is on. It makes more sense if you imagine like a box that's about to fall through a table, but the box is being held up by normal force. If the object is at equilibrium on a horizontal surface, then a normal force is equal to gravitational force. But otherwise, if the object is on like a slant, there's a different calculation that we'll talk about. Applied force is just the force applied to the object, and frictional force is just force of friction. Now, you're going to see a lot of free body diagrams in questions about force. So basically, this diagram is going to show you arrows which label what force it is, and there's going to be a missing value that you need to figure out. You'll also have to draw the diagrams, and it's pretty easy. Just remember that Fg always points down to the earth, Fn goes up, it's the opposite of Fg, Fa is applied force, and Ff is the opposite of Fa. Now, this is a final recap of the main equations. So F net equals ma is really important. This equation is probably like half the force questions that you'll see on a test. Just remember that net force is equal to mass times acceleration. Now, Fg, or gravitational force, is just mass times gravity, but in some questions you'll see a sort of slanted free body diagram, and in this case, you'll need to break up Fg into Fg parallel and Fg perpendicular. So to calculate Fg parallel, you have to do Fg times sine theta, and for Fg perpendicular, you have to do Fg times cos theta, and it'll give you the angles. And like I said earlier, Fn is also just mass times gravity if it's at equilibrium on a horizontal surface. But if the surface is slanted, then Fn is equal to Fg perpendicular. And our final equation is force of friction, which is Ff equals mu Fn. And if you also need to know the kinematics equation, so don't forget that. Now let's do some practice for these concepts. Number 1. A constant unbalanced force of friction acts on a 15 kilogram mass moving along a horizontal surface at 10 meters per second. If the mass is brought to rest in 1.5 seconds, what is the magnitude of the force of friction? So this question tells us that we need to find Ff, or force of friction, but using the Ff equation makes no sense here. The Ff equation is Ff equals mu Fn, and we don't have any of those values. So what we need to realize is that in this question, it says that the object is moving but is then brought to rest. that means that the only force acting on the object is the force of friction, which is making the object stop. So in this situation, force of friction is equal to F net. So we can just use the equation F net equals ma. So F net, it tells us mass right here, 15 kilograms equals 15 kg times, we don't know what acceleration is, but it tells us velocity and time. So acceleration equals v over t. So acceleration equals 10 over 1.5, which is 6.67 meters per second squared. 6.67. And that is going to give us a value of 100 newtons. Number 2. The diagram below represents a block sliding down an incline. Which vector best represents the frictional force acting on the block? So this question is really easy. Just remember the arrows for your free body diagram. So FF is the arrow which is holding the box back from sliding down. So that's going to be B. Number 3. When an object moves at constant speed against friction on a horizontal tabletop, there's an increase in the object's temperature. So this is a concept question. Just know that an increase in friction causes an increase in temperature. Like imagine that you're rubbing your hands together. That friction is what causes warmth. Number 4. An 80-kilogram skier slides on wax skis along a horizontal surface of snow at constant velocity while pushing with his poles. What is the horizontal force pushing him forward? So when we see the phrase wax skis on snow, we should know that they're talking about friction because that is one of the surfaces on the coefficient of friction section in the reference table. So we need to use the equation FF equals mu Fn. So how do we find Fn? It tells us the mass of the skier here, and it also tells us that he is on a horizontal surface at constant velocity. So let's use our logic here. We should know that normal force is equal to gravitational force when normal force is at equilibrium on a horizontal surface, which is this exact situation. So this perfectly lets us use the fact that Fn is equal to Fg, which is equal to mg. So Fn equals mg. Fn equals 80 kilograms times 9.81 meters per second squared. And that's going to give us 784.8 newtons. Now we just plug in. So force of friction equals, if we look on the reference table, it tells us that the coefficient of friction for wax skis on snow is 0.05 times 784.8 newtons, and we're going to get 40 newtons, which is choice C. Number 5. In the diagram below, surface B of the wooden block has the same texture as surface A, but twice the area of surface A. If force F is required to slide the block at constant speed across the table on surface A, approximately what force is required to slide the block at constant speed across the table on surface B? So the answer here is going to be F, because remember, the only thing that affects coefficient of friction is the texture, and it says here that surface B and surface A have the same texture, so there's going to be no change. Number 6. A book weighing 20 newtons slides at constant velocity down a ramp inclined 30 degrees to the horizontal as shown in the diagram below. What is the force of friction between the book and the ramp? So the first thing we can do in this equation is eliminate choices A and B, because force of friction would be going up the ramp like this, not down. Now the book is going down a slant, so FG is split into FG parallel and FG perpendicular. Let me draw this out. So this is what regular FG looks like, and this is what FG parallel would look like, and this is what FG perpendicular looks like. So it tells us that the book is going down at constant velocity, meaning that all forces are balanced. See here, let's look at FG parallel and FF. These are opposite to each other, and since it's going down at constant velocity, all forces are balanced. So FG parallel is equal to FF in this situation. So instead of solving for FF, we can just solve for FG parallel. So FG parallel equals FG times sine theta. So FG parallel equals FG is 20 newtons sine 30. And our answer here is going to be 10 newtons. So I'm going to skip 7 and 8 because these questions have nothing to do with this current topic and go on to question 9. So if a 30 Newton force is required to accelerate a 2 kilogram object at 10 meters per second squared over a level floor, the magnitude of the frictional force acting on the object is what? So in this question, it gives us mass and acceleration. So that's a dead giveaway to use F net equals ma. So after we plug everything in, it should tell us F net equals 2 kilograms times 10 meters per second squared. F net is equal to 20 newtons. So if it takes an applied force of 30 newtons to accelerate the object, that means there's a 10 Newton force holding it back to give the object a net force of 20 newtons. Let me draw this out. So this is the box, right? It says that there's a 30 Newton force here, and there's a net force of 20 newtons. So that has to be a 10 Newton force holding it back. So the frictional force is this 10 Newton force. Number 10, according to your reference table, approximate coefficients of friction, what is the minimum horizontal force needed to start a 300 Newton steel block on a steel table in motion? So this question is pretty easy. It's just asking us for FF. So we do FF equals mu Fn. And we just plug in. So if we look on the reference table, steel block on steel, that's FF equals 0.74, and it tells us normal force right there, 300 newtons, and we'll solve and get 222 newtons. Number 11, sand is often placed on an icy road because the sand increases the coefficient of friction between the tires of a car and the road. So this one's just common sense. Ice would probably cause the car to slip and slide, so the sand would increase friction to prevent that from happening. Number 12. A box decelerates as it moves to the right along a horizontal surface as shown in the diagram. Which vector best represents the force of friction on the box? So this is going to be B. This is what force of friction would look like. So if we look here, remember that the vector of FF is opposite to the box's motion. So since the box is moving this way, it's just going to be the opposite of that. 13. A box initially at rest on a level floor is being acted upon by a variable horizontal force, as shown in the diagram at the right. Compared to the force required to start the box moving, the force required to keep it moving at constant speed is less. So, remember that it takes more effort to make something start moving than to keep it moving, aka coefficient of static friction is bigger than coefficient of kinetic friction. 14. The diagram below shows a 4 kilogram object accelerating at 10 meters per second squared on a rough horizontal surface. What is the magnitude of the frictional force, FF, acting on the object? So this question is similar to number 9 as it gives us mass and acceleration, so we can find the net force on the object. So we just do F net equals ma. So F net equals 4 kg times 10 meters per second squared, and that's 40 newtons. So if the applied force is 50 newtons, but the net force is 40 newtons, how would that work? That means that we need a frictional force of 10 newtons. Like, for example, I'll just write out the math. So negative 10 newtons plus 50 newtons would equal that net force of 40 newtons. So our answer is going to be B. 15. The diagram below shows a block sliding down a plane inclined at angle theta with the horizontal. As angle theta is increased, the coefficient of kinetic friction between the bottom surface of the block and the surface of the incline will remain the same. So remember that coefficient of static and kinetic friction only rely on the texture of the surfaces. Nothing else affects it. So the angle would not affect it. So it remains the same. 16. In the diagram below, the upward drag force acting on a parachute is equal in magnitude but opposite in direction to the weight of the parachutist and equipment. As a result of the forces shown, the parachutist may be moving C, downward at constant speed. So the drag force and weight have the same magnitude, which means that it is moving at constant velocity. Imagine it's 30 newtons here going this way and 30 newtons here going down this way. That puts it at equilibrium, aka constant velocity. 17. The diagram below shows a student applying a 10 Newton force to slide a piece of wood at constant speed across a horizontal surface. After the wood is cut in half, one piece is placed on top of the other as shown. What is the magnitude of the force F required to slide the stacked wood at constant speed across the surface? So this is going to be B, 10 newtons. So it stays 10 newtons because stacking the wood doesn't actually do anything. Remember, stacking the wood, it does nothing. Everything that friction relies on is just about the texture, and the texture stays the same. 18. The force required to start an object sliding across a uniform horizontal surface is larger than the force required to keep the object sliding at a constant velocity. The magnitudes of the required forces are different in these situations because the force of kinetic friction is less than the force of static friction. Remember, we talked about this earlier. Once again, this is greater than this. 19. A 0.5 kilogram puck sliding on a horizontal shuffleboard court is slowed to rest by a frictional force of 1.2 newtons. What is the coefficient of kinetic friction between the puck and the surface of the shuffleboard? So this question is pretty easy. We just use the equation for FF. So FF equals mu Fn. It tells us that force of friction is 1.2 newtons. That equals mu, and then it tells us 0.5 kilogram puck. So to find Fn, we would just do 0.5 kilograms times 9.81, and we would get 4.9 newtons, and we would solve and get a coefficient of friction of 0.24, which is A. 20. A car's performance is tested on various horizontal road surfaces. The brakes are applied, causing the rubber tires of the car to slide along the road without rolling. The tires encountered the greatest force of friction to stop the car on C, dry concrete. So if we look at the reference table, we can find all the coefficient of friction values, and the highest value is our answer. So the highest value here is dry concrete. 21. The diagram below represents a box shown sliding down an inclined plane. Toward which point will the force of friction on the box be directed? So the velocity is going towards C right here. 3. And remember, FF is the opposite of applied force. So FF would be going the opposite way, which is 2. And that's going to give us B. So now we should kind of understand these concepts. The rest of these questions on this worksheet are pretty easy, so we're going to switch to another one. Number 1. The graph represents the net force acting on an object as a function of time. During which time interval is the velocity of the object constant? So constant velocity is when your net force is 0, so that is this interval of 3 to 4 seconds, which is answer A. Number 2. Two forces, F1 and F2, are applied to a block on a frictionless horizontal surface as shown below. If the magnitude of the block's acceleration is 2 meters per second squared, what is the mass of the block? So on this free body diagram, it tells us that there is a force of 12 newtons moving to the left and a force of 2 newtons moving right. So there is a net force, F net, of 10 newtons. So we just plug this into the equation, F net equals MA. So 10 newtons equals mass times an acceleration of 2 meters per second squared, and that is a mass of 5 kilograms, which is choice B. Number 3. A carpenter hits a nail with a hammer. Compared to the magnitude of the force the hammer exerts on the nail, the magnitude of the force the nail exerts on the hammer during contact is the same. So this is Newton's third law. For every action, there's an equal and opposite reaction. Number 4. A cannonball with a mass of 1 kilogram is fired horizontally from a 500 kilogram cannon, initially at rest on a horizontal frictionless surface. The cannonball is acted on by an average force of 8 times 10 to the third newtons for 1 times 10 to the negative 1 second. What is the magnitude of the average net force acting on the cannon? So don't get tricked by the wording of this question. It's super easy. It's just saying that there's a force of 8 times 10 to the third newtons, and that's the answer. Number 5. A horizontal force is used to pull a 5 kilogram cart at a constant speed of 5 meters per second across the floor, as shown in the diagram below. If the force of friction between the cart and the floor is 10 newtons, the magnitude of the horizontal force along the handle of the cart is what? So it says the cart is moving at constant speed, so it's at equilibrium, meaning that net forces are equal to 0. So it also says that since it's equal to 0, the applied force is equal to the force of friction. So that means that the answer is 10. If we're looking for the horizontal force, it tells us that the force of friction is 10, and horizontal force or applied force is equal to frictional force. Number 6. A student is standing in an elevator that is accelerating downwards. The force that the student exerts on the floor of the elevator must be B, less than the weight of the student when at rest. So imagine yourself standing in an elevator that's going down a bunch of floors. When this happens, you feel like you weigh less and that your feet might lift off the ground a little. This tells us that the force that you're exerting on the floor of the elevator is less when it's accelerating downwards in comparison to when you're exerting your full force on a resting elevator floor. Number 7. A net force of 10 newtons accelerates an object at 5 meters per second squared. What net force would be required to accelerate the same object at 1 meter per second squared? So this question is really easy. It tells us the F net of an object at 5 meters per second squared. So we use F net equals ma to find out what mass is, and then plug the numbers back in to find F net of that same object but at 1 meter per second squared. So F net equals ma. Let's plug in. So 10 newtons is equal to mass, which we were trying to find, times 5 meters per second squared. This tells us that mass equals 2 kilograms. So now we plug back in, but with an acceleration of 1 meter per second squared. So F net equals, 2 kilograms times 1 meter per second squared. And that means it's an F net of 2 newtons. So that's choice C. 8. 2 carts, A and B, are joined by a compressed spring as shown in the diagram below. The mass of cart A is twice that of cart B. Which of the following statements is true about their change in velocity when the spring is released? So this question seems kind of confusing, but it's just about inertia. Remember that, inertia. So remember that inertia is the same thing as mass, and it's harder to change the movement of an object with more inertia rather than the movement of an object with less inertia. So since cart A has twice the mass or twice the inertia as cart B, it's harder to change the movement of cart A and easier to change the movement of cart B, which is why cart B would have a greater change in velocity. Number 9. The diagram below shows a compressed spring between 2 carts initially at rest on a horizontal frictionless surface. Cart A has a mass of 2 kilograms and cart B has a mass of 1 kilogram. A string holds the cart together. The string is cut and the carts move apart. Compared to the magnitude of the force the spring exerts on cart A, the magnitude of the force the spring exerts on cart B is the same. So this one's easy. It's just saying that Newton's third law, so the spring exerts the same force on cart A as cart B. And I'm going to skip 10 and 11 because they're kind of easy. So number 12. A man weighs 900 newtons standing on a scale in a stationary elevator. If sometime later the reading on the scale is 1200 newtons, the elevator must be moving with constant acceleration upward. So once again, just imagine that you're in an elevator, but this time you're going in an elevator that's moving up a bunch of floors. So it feels like you're heavier because the floor is pushing up onto your feet. So since this man is going from 900 newtons to 1200 newtons, that's the result of increased force which upward acceleration in an elevator causes. 13. When the sum of all the forces acting on a block on an inclined plane is 0, the block may be moving at constant speed. So just read the answers really carefully. Remember, when net force is equal to 0, it could be because the object is at rest or at constant velocity. So A is wrong because it's saying that it must be at rest when it could also be at constant velocity. But B is correct because it's saying may. 14. A car is uniformly accelerating from rest. The net force acting on the cart is C, constant. Keyword uniformly. So now we're going to go and do a few short response questions. Number 1. A 30-kilogram block that is attached to a rope is being pulled up a ramp at a constant speed of 11 meters per second. If the ramp makes an angle of 50 degrees to the horizontal and is being pulled up with a force of 233.01 newtons, determine what the surfaces are made of. So I already drew like a little free body diagram here, but we're finding out what the surfaces are made of. So that tells us we need to solve for force of friction at some point, because we need the FF equals mu Fn equation to solve for coefficient of friction. So the first step we should do here is find out what Fn is. So since we're on a slant, that tells us that Fn equals Fg perpendicular. So we don't have Fg yet, so let's solve for Fg. So Fg equals mg, which is 30 kilograms times 9.81 meters per second squared, which is 294.3 newtons. So now we have Fg, we can solve for Fg perpendicular, which is Fg times cos theta. So 294.3 newtons cos 50, because it's 50 degrees. And this is 189.17 newtons. So this is also equal to Fn. So now we have Fn, we have to solve for FF. Okay, so I went ahead and added some more stuff to the free body diagram, but now our next step is to find FF. So the thing here is that it says that the block is moving at constant speed. It's being pulled at constant speed. So we know that F net is equal to 0. But in this case, that does not mean that FF equals FA. So FF does not equal FA. So the force applied, or the pull force, is 233.01 newtons. And this balances out the total opposing forces of the block, which are both FF and FG parallel. If you look at the free body diagram, so this is FA. That's the 233.01 newtons. There's also 223.01 newtons over here, but it's combined. So 233.01 newtons equals FF plus FG. Okay. So, in order to find FF, we need to find FG parallel first, because basically it's saying that FA, or the pull force, equals FF plus FG parallel. So, FG parallel is FG sine theta. So 294.3 newtons sine 50 is equal to 225.45 newtons. So we know what FA is, 233.01 newtons. That equals FF plus 225.45 newtons. So the force of friction is only equal to 7.56 newtons. Now, our final step is to plug everything back into FF equals mu Fn to solve for the coefficient of friction. So, FF, 7.56 newtons, equals mu times mu times 189.17 newtons. And that is going to give us a value of 0.04. And this is equal to Teflon on Teflon. And you could just find that out by checking the reference table. Number 2, a 16-kilogram block is at rest on an incline that is 27.92 degrees to the horizontal. If this is the tipping point for the block, determine what the surfaces are made of. So this question is asking us to find what the surfaces are, so we need to find the coefficient of friction. Specifically, we need to find the coefficient of static friction because the block is at rest. I haven't talked about this yet, but the equation for coefficient of static friction on an incline is literally just tan theta. So coefficient of static friction is equal to tan theta. So the only thing we need to do to solve this question is just plug in. So tan of 27.92 degrees. And that's equal to 0.53. And if we look on the reference table, this is copper on steel, which is our answer. Number 3. A high school student with a mass of 70 kilograms is standing on a scale in an elevator. The student looks down and notices their apparent weight is 575 newtons. What is the magnitude and direction of the acceleration that is acting on the student? So we know that the mass of the student is 70 kilograms, so let's solve for their real weight, or their Fg, by using Fg equals mg. So Fg equals 70 kilograms times 9.81 meters per second squared, and we're going to get 686.7 newtons. So now we know that their real weight is 686.7 newtons, but it says that their apparent weight is 575 newtons. And let me clear up this first. Fn in this case, or normal force, is equal to apparent weight. So the reason why apparent weight and Fn are the same thing is because your Fn will keep adjusting to counteract the gravity and acceleration from the elevator. So Fn is equal to 575 newtons. So now we have Fn and Fg, but we need to solve for acceleration. And the only way that we can solve for acceleration is through F net equals ma. But we don't have F net yet. So remember, F net, or the net force, is the total forces acting on an object. So in this case, the only forces that are acting on the student is Fn and Fg. So F net is equal to Fn plus Fg. But since they're going in opposite directions, see how Fn is going up and Fg is going down, we have to negate one of them. So I'm going to negate Fg. Now we just plug in to solve. So F net equals 575 newtons plus negative 686.7 newtons. And that's going to give us a value of negative 111.7 newtons for F net. Now we can plug this back into the F net equals ma equation to find acceleration. So negative 111.7 newtons equals mass of 70 kilograms times acceleration. We're going to get an acceleration of negative 1.6 meters per second squared. And that shows us that it's going down. So this would be our answer. Number 4. You are driving a 1,500 kilogram car at a constant speed of 20 meters per second along an icy but straight level road. As you approach an intersection, the traffic light turns red. You slam on the brakes, the wheels lock, and the tires begin skidding, and the car eventually slides to a halt. How long will it take the car to come to a stop if the coefficient of kinetic friction between the tires and the road is 0.27? So the final goal for this question is to find time, and we can only find time through our kinematics equations. The connection here between these forces equations and the kinematics equations is acceleration. So at some point in solving this question, we need to find acceleration. So first, we're just going to solve for a bunch of things and then connect it back to acceleration. So we have the mass of the car, so we should just find Fg first, using the equation Fg equals mg. So 1,500 kilograms times 9.81 meters per second squared equals 14,715 newtons. Also, keep in mind it says that the car is on a straight level road at constant velocity. So that means in this situation, Fg is equal to Fn, because Fn and Fg are equal to each other when the object is at equilibrium on a horizontal flat surface, and that applies to this case. So now that we know that Fg equals Fn, we can use the equation Ff equals mu Fn to solve for Ff, because now we have Fn. So Ff equals, it gives us coefficient of friction 0.27 times 14,715 newtons, and that's going to give us a value of 3,973.05 newtons for Ff. Now, we know what Ff is, so let's connect that back to F net, because we need to use the equation F net equals ma to solve for acceleration. So remember, in this question, it says that the car is braking. So the only force being applied to the car is the force of friction, which is stopping it. So in this scenario, Ff equals F net. So now that we know that Ff and F net are the same thing, we can just plug in F net equals ma. So 3,973.05 newtons equals 1,500 kilograms times acceleration. We're going to get an acceleration of 2.65 meters per second squared. But it's going to be negative because remember, we're slowing down. Now we have to use our kinematics equations. So we're going to we're going to list out all the values we know. So we know that the initial speed, or VI, is 20 meters per second. It comes to a halt, so our final speed, or VF, is 0. Our acceleration is negative 2.65 meters per second squared, and we're solving for time. So with all of this, we can use the equation VF equals VIT. Oh shoot, I lied. VF equals VI plus AT. Oops. Anyways, let's plug in. So 0 equals 20 meters per second plus negative 2.65 meters per second squared times time. And once you solve this out, you're going to get a time of 7.55 seconds. And that's our answer.